In this segment, we'll talk about what machine learning is at a high level, providing a definition, describing common examples of machine learning, introducing terminology we'll be using throughout the course, and defining the two learning settings that we'll be studying. So let's start with a definition of machine learning. It's a wide-ranging field and can be roughly defined as constructing and studying methods that learn from and make predictions on data. This broad area involves tools and ideas from various domains, including computer science, probability and statistics, optimization, and linear algebra. Common examples of machine learning include face recognition, link prediction, text or document classification, for instance, spam detection, which is a canonical example of machine learning, protein structure prediction, or in other words, trying to predict a protein's 3D structure given its amino acid sequence, and teaching computers to play games, such as backgammon or Jeopardy. Now let's introduce some common terminology we'll be using throughout this course. And to make this more concrete, we'll use the example of spam detection as a running example. So recall that machine learning involves learning from data, and these data points we'll call observations. And observations are items or entities used for learning or evaluation. And in the context of spam detection, emails are our observations. Features are attributes used to represent an observation. Features are typically numeric, and in the context of spam detection, they can be, for instance, the length, the date, or the presence or absence of keywords in emails. Labels are values or categories assigned to observations. And again, in the context of spam detection, these can be an email being defined as spam or not spam. Training and test data sets are the observations that we use to train and evaluate a learning algorithm. Again, for instance, in the context of spam detection, this can be a set of emails along with their labels. The training data set is what we give to a learning algorithm in order to train it. And in contrast, a test data set is something that we withhold at training time and subsequently use to evaluate the algorithm that the learning model that we've devised. Now let's consider the two common learning settings that we'll be focused on during this course. The first setting, called supervised learning, involves learning from labeled observations. The idea here is that the labels teach the algorithm to learn a mapping from observations to labels. In contrast, in unsupervised learning, we're forced to learn solely from unlabeled observations. And here, a learning algorithm must find latent structure in the features alone. And there's two main reasons why we might want to perform unsupervised learning. One is that it can be a goal in and of itself to better understand our data, to discover hidden patterns, or to perform exploratory data analysis. Alternatively, it can be a means to an end. It can be, in some sense, a pre-processing step before we perform a downstream supervised learning task. So what are some common examples of both supervised and unsupervised learning? Well, in the supervised setting, classification is one common task, and the goal here is to assign a category to each item. For instance, spam detection is a common binary classification problem. Here, the categories or the labels that we're trying to predict are discrete, and there's generally no notion of closeness in the multi-class classification setting. In contrast, regression is another supervised learning setting where we aim to predict a real value for each item, for instance, trying to predict stock prices. Here, our labels are continuous, and we can, in fact, define closeness when comparing predictions with labels. Now considering unsupervised learning, clustering is one common unsupervised learning task. The goal here is to partition observations into homogeneous regions, for instance, to try to identify communities within large groups in a social network. A second common unsupervised learning task is dimensionality reduction. Here, the goal is to transform an initial feature representation into a more concise one. For instance, trying to find a more concise representation of high-dimensional digital images, represented initially as pixels.